Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is question number 6.11. A 4 millifarad capacitor has a current waveform shown in figure 6.48. Assuming that V of 0 is equal to 10 volts, sketch the voltage waveform V of t. So the waveform given here is I of t in milliamps with respect to time. So we need to sketch the voltage waveform V of t. So we are going to find out what is V of t here, right? So we should know the formula relating this VI characteristics of the capacitor. For capacitor, this V of t is equal to 1 by C integral T naught to T I of tau d tau plus V of that initial voltage. So this is the formula to be applied. So in our case, the capacitance value is given as 4 millifarad and this V of 0 is given as 10 ohms. Okay, other than that, we have to interpret this mathematical value from this graph. How do you interpret this current waveform into a mathematical one? So I of t is equal to 15 milliamps for the time period the 0 to 2. Okay, so for t lies between 0 seconds to 2 seconds, and from 2 to 4 the next time period I of t value is equal to, it is minus 10. So it is minus 10 milliamps for the time period 2 to 4 seconds, and it is equal to 0 for the time period 4 to 6, and this is equal to 10 milliamps for the time period 8 seconds for the time period lies between 6 to 8 seconds. Okay, so this is the one we are going to use in this formula. So this V of t is equal to 1 by C value is 1 by C value is 4 into 10 power minus 3 because it is 4 millifarad integral T naught is 0, then you take this as t only, right? Because we want the equation in terms of t. We are not going to get the whole value. First, initially we'll get the V of t in terms of t. Okay, so I of tau value is 15 milliamps in this case. So it is 15 milliamps means 15 into 10 power minus 3 d tau plus V of 0 is 10. This is how we have to write. Okay, so this is equal to 15 into 10 power minus 3 divided by 4 into 10 power minus 3. So you can cancel these two, and then for this is being already taken outside, right? Only you have this t tau. For the t tau, the integration is tau. And the limit is 0 to t plus this 10. So 15 by 4 is equal to 3.75. This is 3.75, and this you can apply the upper limit minus this lower limit, that is 0 plus this 10. So this is equal to 3.75 t plus 10. Okay, this is your V of t for the first one. So let me take this as the first equation. So this is the voltage equation we have got for this current, okay, for this time period 0 to 2 seconds. But whenever you want to proceed for the next time period 2 to 4 seconds, we should know the initial value. Okay, initial value is the voltage which is available at the 2 seconds. So what is the initial value which is available at the 2 seconds? So you should find V of 2, that means 2 seconds, that is equal to 3.75 into 2 plus this 10. 7.5 plus 10, so that is equal to 17.5 volts. So again we should notice this. So V of 2 is equal to 17.5 volts. So this also we need. Okay, now we move on to the second. Okay, the second equation, it is I of t equal to minus 10 milliamps for the time period lies between 2 to 4 seconds. So what is that V of t? V of t is equal to 1 by c is 1 by 4 into 10 power minus 3 integral t naught to t. T naught value is here, it is 2, right? So lower limit, it is 2. Here upper limit you put it as t, because then only you will get the equation in terms of time. And what is this I of t? I of t value is minus 10 milliamps. So it is minus 10 into 10 power minus 3 d tau plus what is V of t naught? T naught here is V of 2. Okay, that is the initial value, right? So it is V of 2. So this is equal to, here you can cancel these two, and this is constant, right? So minus 10 by 4, right? Minus 10 by 4, and integral 2 to t d tau is there, right? D tau value, while integrated you get it as tau. The limit is 2 to t plus V of 2 is 17.5, because we know that this is the V of 2. Okay, so this is equal to minus 2.5. Tau is, you have to substitute the upper limit as its t and the lower limit as 2 plus the 17.5. So this is equal to minus 2.5 t minus of minus plus 5 plus 17.5. So this is equal to minus 2.5 t plus 22.5. So this is V of t. This is your third equation. V of 4 value is equal to, that is the voltage at 4 seconds, that is equal to minus 2.5 into 4 plus 22.5, that is it is minus 10 plus 22.5, so that is equal to 12.5 volts. So V of 4 is equal to 12.5. So we have this formula, but now we are going to apply it for this third equation of I of t. So V of t is equal to 1 by c is 1 by 4 into 10 power minus 3, and here you have this value as 0. 0 into d tau plus V of 4 is 12.5. So this is 0 plus 12.5, that is equal to 12.5. So this V of t is the range that lies between this 4 and 6 seconds. So that value is 12.5. So let me take this as fifth equation. So this V of t is throughout this time period 4 to 6, it would be having the value of 12.5 volts only. Now we can find out the voltage equation for this time period 6 to 8 seconds. So it is V of t is equal to 1 by c is 1 by 4 into 10 power minus 3. Integral t naught is 6. Here it is t. I of tau d tau, that is 10 milliamps, right? So it is 10 into 10 power minus 3 d tau plus V of 6 is 12.5. So this is equal to, these two get cancelled, then 10 by 4 will be there, and d tau while integrated it becomes tau, and the limits are 6 to t plus 12.5. So this is equal to 2.5. 10 by 4 is 2.5, and this becomes t minus 6 when you apply the upper limit and the lower limit plus this 12.5. So this is equal to 2.5t minus 2.5t minus 2.5 into 6, that is 15 plus 12.5. So that is equal to 2.5t, that is equal to 2.5t minus 2.5. So this is V of t for the time period 6 to 8 seconds. So this is our sixth equation. In this equation, actually we want to find out the last value, that is V of 8 seconds, that is equal to 2.5 into 8, because t is 8 seconds, right, minus 2.5. So that is equal to 17.5. This is equal to 17.5 volts. So V of 8 is equal to 17.5. So now we can write the mathematical equation for this V of t. So now we can plot this. First we'll take this, right? V of t equal to 3.75 t plus 10. So at this, when you put 0 for this t, you will put 0, apply here, then you will be getting 10. But initially in the problem it is given as V of 0 is equal to 10 ohms, right? So here itself we can mark the 0 time period, the value is 10. So we mark this first one. Okay, then 2 seconds. When it is 2 seconds, we have calculated already. So V of 2 is equal to 17.5, already we have calculated, and V of 4 also we have calculated as 12.5, and V of 6 also equal to 12.5, and V of 8 is equal to, it is 17.5 again. So using this we can calculate easily. Otherwise, using this equation also you should be able to, you can easily get the value. For example, for this 0 you can apply the 0 here, so that you will get the 10 voltage, okay, at t equal to 0. And when you apply t is equal to 2 seconds, that means here it is 2, so that becomes 7.5, right? 7.5 plus 10, then it is equal to 17.5 volts. So at 2 seconds you will be getting this as 17.5 volts. Then here you are coming to the second equation. Here again, if you even apply 2 seconds, here this becomes 2, right? So minus 2.5 into 2, it becomes minus 5 plus 22.5, that becomes 17.5. So there is no need to calculate it again, because we have already calculated in the previous equation itself. Okay, so V of 2 is anyhow 17.5. But what is V of 4? V of 4, just substitute 4 seconds here. So that is equal to minus 10 plus this 22.5, that becomes this 12.5. Okay, so we got this 12.5 volts. Again this 4 to 6, already we got the constant value of 12.5 volts. Then we go for this 6 seconds, already calculated as 12.5. Already we have calculated. Anyhow, once again I am telling you, for this t you substitute 8, so 2.5 into 8, that becomes 20. 2.5 into 8, that becomes 20. 20 minus this 2.5, that becomes 17.5. Okay, this is 17.5. That's how we got this. So after getting this, we can plot it. So it is V of 0, that means t equal to 0 time value is 10 volts. Okay, sorry, this is V of t in volts, right? So V of 2 is 17.5. So for this 2 seconds, it is 17.5. So it comes around here, 17.5. So you can join these two. So you'll get this. Now V of 4 is 12.5. So 12.5 means it would be, for 4 it is 12.5, means it comes here. So you can join these 2 points. Now V of 6, it is also 12.5. So we can join these 2. Then what is V of 8? V of 8 is 17.5 again. So it would be here, coming here, right? It is coming here, 17.5 volts. Now we can join these 2 points. That's it. I hope you have understood.